So over these 5 sessions, we're going to cover the philosophy and practice of using NEMS. We're going to work through all the steps in the order that you actually undertake a project. And we're going to introduce you to some of the work that's been done in the Pacific and some of the opportunity and how to work out if you're going to be involved in a NEMS program, how you figure out what to actually do for your country. So the sessions build on each other. It won't matter if you do get one out of sync, but it is good if you can follow along in the order that we're presenting them if possible. There's quite a lot of information that we're sharing. We are going to make these PowerPoint presentations available as well as the recordings, but also I draw your attention to this Pacific battler that we produced, or Spret produced last year. And everything we're saying pretty much today is written down in this document. So if you haven't already downloaded a copy from the Spret website, I suggest you do so, and you can refer back to the comments if you know, and read in more detail and review. But first of all, we have to start with the big picture. And, you know, what is it about weeds and why do some plants go bad? So when we're talking about weeds, they're not plants that are native to your countries. They have been introduced. And we see here a picture. This is from Niue. This is the taro vine. Very scary vine. Terrible plant. And so why has this plant gone so bad when it's been moved to Niue? They often grow really well because the conditions in the new country are favourable. Nice soil, sunshine, moisture. But we also think it's very, the fact that they have left behind their natural enemies in their home country, they have evolved to have natural enemies which control them. All native plants have their own natural enemies as part of nature. And when they get separated, they don't have the things that keep them in balance, and they develop a competitive advantage over the native plants and the other plants that you want to have. And they go mad and they grow too big and too fast, and they take over. And we also need to put this into context. Really, these are the things to think about very hard. The most important thing to do is to stop new weeds coming into your country. You have already got plenty. You don't want any more. And it's too easy for new plants to come in and create you more problems. So the first thing is always to stop any more new plants, any more new weeds coming in. The second step is when plants go bad and become weeds, we need to work that out early and eradicate them. And so there is a program which Spret runs with Brad Meyer leading, which is looking to do that. So when there's not so many, they're just starting to take off, you can get out the herbicide, or you can get out the shovel, get out your gloves, rip them out, pull them out, get rid of them. And you can stop them being spread from island to island, or even within islands. Try not to let them get away. We need to, if we can't eradicate them, at least contain them. And we only get into doing the natural enemies when that's too late. When the weeds are too widespread, they're too serious. It's no longer possible, feasible, affordable to eradicate them or to control them or to manage them any other way. And there's a picture here of Michael with a very nasty weed called Puccinia. And that's one of the ones, if you don't already have it in your country, you don't want to get, or you don't want to spread to other islands. So there's all these steps that we do before we even get to thinking about NEMS. And when it's not feasible to eradicate, often using natural enemies is going to be your best option, the least damaging option, and probably the only sustainable one. We know that chemicals can be used very successfully and safely to control weeds, but we also know that it's becoming increasingly difficult to use them in some places because of concerns around safety. and harmful flow-on effects. It's also the cost. Now, I've got a couple of pictures here which I'm going to explain to you, which I think are rather gorgeous. The hall in Australia is dedicated to this caterpillar, which saved Australia, in particular Queensland, where Michael's based, from being overrun by a very nasty prickly cactus. And the community was so grateful, they erected a hall in honour of the caterpillar. And below, there's a monument in the United States to a beetle, which again saved farmers from walking off the land when a very serious weed called St. John's wort took over and they had no answer. So communities can be incredibly grateful that these natural enemies can save the country from being overrun by weeds and having to walk away from the land and having no solutions. So I wonder what our monument will be in the Pacific in the future. That's one for us to think about. So when we're using natural enemies, and sometimes this is referred to as biocontrol or biological control, we're trying to restore that natural balance that normally exists between a plant and its environment. And that's by reintroducing to the weed the natural enemies that it had become separated from. But we're only interested in natural enemies that won't attack other desirable species or cause any unwanted issues. We're not interested in creating any more problems. And so we're only going to proceed if it's safe to do so. And there are some advantages to using the natural enemies. It is the only sustainable way of managing widespread weeds, because once the natural enemies are released and established, they provide permanent suppression, hopefully forever. And so nobody ever has to spend any money or make any effort controlling those weeds again. And we all know if you're resorting to having to manage weeds by spraying or pulling them out or getting your bush knife to cut them back, you have to keep doing it over and over because they keep growing back. It's also very highly cost effective, although it does cost money to do the research, to find the natural enemies, to test them, to make sure they're safe, to work through the steps of importing them and getting the infrastructure in place in your countries. The mass rearing of them, the release of them, this all costs money. But once that money's spent, you don't have to spend it again. It's a one-off cost. And it works out to be very, very highly cost effective to develop the natural enemies. And particularly where we can share them in the Pacific with each other, that makes it even more cost effective. It can be very little extra expense if a country already has a natural enemy and it's able to share it with another country. We're not having to start new projects completely from scratch. We can guarantee that only the target plant, the weed that we don't want, will be damaged. And we're going to, in another session, go into detail about how we can be sure about that. There's also no health risks. We're not working with any insects that would sting or bite you or have any harmful effects to humans or animals. They are completely benign. And you don't have to wear any special safety gear with these natural enemies. Another advantage is that the weeds are removed gradually. And initially that might sound a bit strange. We're all in a hurry. We all want to get things done. We want to get rid of these invasive species. We want to get our biodiversity back. We want the land back for growing crops. So why is it good that this happens slowly? Well, the answer to that is that if you create a space, that's often not a good thing. If you take the weed out too quickly, it might just get replaced by another weed. It might be a worse weed. Or you might have a bad storm and you might have soil or a hillside get washed away because there's no plants holding the soil together anymore. So when we're repairing an ecosystem, it is better to do it slowly and to take our time and to make sure we are replacing those weeds with other, better, more desirable vegetation. So while we're in a hurry, we need to slow down and we need to get this right. Another advantage is that it works across the landscape. So it doesn't matter if the weed is growing on a cliff. It doesn't matter if the weed is growing on a piece of land where the farmer doesn't pay much attention. It will work anywhere that the weed is. And that's obviously something you can't do. We're using manual control. And you might again think this is a bit of a strange one, that we think it's an advantage that we're not actually going to eradicate the weed. So with natural enemies, you're never going to eradicate a weed. We're going to reduce it to a level that we can live with, where the harmful impacts are no longer serious. It just becomes another minor plant there in the landscape. It's not possible to eradicate weeds with this approach. And there are some good reasons sometimes, and we'll talk about this a bit more too in another session, is that sometimes weeds aren't all bad. Sometimes they are useful. You might want the flowers to make decorations. You might want the wood of a tree to make a fence post. You might want the leaves of a plant for a medicine. So you can still have the weeds, just less of them, so you can still use them for the things that they are good for, but they're not taking over at the cost of everything else. But we also have to be mindful of the disadvantages. And working with natural enemies can be quite a slow process. We have to do sometimes years of research to find suitable natural enemies. So we're just starting now to look for what might be possible for the Singapore daisy, for the taro vine, for example. It's going to be years before there might be natural enemies available for them. But when we have natural enemies that are already known and readily available, we can get going a lot more quickly. And in the Pacific, the good thing is that because it's warm, it happens a lot faster than it happens in countries like New Zealand where it's colder. So some of the work that I've been doing in the 30 years in New Zealand, it can take that long to see the results. And as Michael will show you some pictures, we had seen results in the Pacific in a year or less, quite dramatic differences. So it's not going to get the weed knocked back within a week or a month, but in some cases, you're going to see results within a year or a couple of years. When we say no guarantees, there are some things we can guarantee. What we can't guarantee is that the level of control will be exactly the same, that each natural enemy will have the same impact everywhere it's released. So there are often niches which suit natural enemies, some better than others. Some like it to be moist, some like it to be dry, just for an example. We can guarantee safety. We absolutely guarantee safety. But sometimes you have to try a natural enemy to see how well it works in your country. And the level of control can vary. So some of you live on islands where you might have a wet side and a dry side, and an agent might work better on one side than the other. Or even if you have a year that's a wet year and a dry year, you might get a slightly different level of control. So it's not like spraying with a chemical where you know exactly what you're going to get. There is an element of having to do this and see how it works. And if we're not getting enough control, then we can go back to our toolbox of natural enemies and look at whether there are other ones we can add to increase the level of control that's required. And for some, it will be a disadvantage that we can't eliminate the weed. but that's part of natural enemies. And it is ideally land managers will have some knowledge of the natural enemies and how it works. And this is particularly maybe important if you have a situation like with farmers and pasture weeds. If they don't know that you've got natural enemies that you've released and they go and mow it with their tractor, that might stop the natural enemies from taking hold and doing the job, and it might just prevent them from doing the job they need to do in your country. So sometimes it's important that farmers and land managers know about this and understand how to make it work. But also on the flip side, these natural enemies will work even if people don't know about them and people don't believe in them. They just get on and they do their job. Okay, so here's our cane toads, our miners, the mongoose, African snail. We could put more pictures up, but these are the ones that people mostly talk about first. And there's a big red cross through this, and that's because we are nothing to do with any of these disastrous introduced species. We totally distance ourselves from this. In each of these instances, people made very bad choices to introduce these to countries. They were not specialist natural enemies. They can all feed on lots of things, and they were bad mistakes that were made in the past, and people will remember these forever and remind us about them. But this has nothing to do with using natural enemies for weeds, and I'm going to explain this a little bit more. So safety is always front of mind for all of us. And we can be reassured because this is not new. It has become a bit of a forgotten tool in the Pacific in the last few decades. But there's 100 years that natural enemies have been used in the Pacific to safely control weeds. So we can look back over 100 years, and at least 91 countries have introduced at least one natural enemy. Nearly 200 weeds have been tackled by this approach in the world. About 500 natural enemies have been deliberately released to control weeds. And you can find out all this information. There's a link there to an online catalogue. There's also hard copies of the book available. And there's a very good resource. We know what has happened over 100 years with all these countries and all these natural enemies and all the weeds. We have very good data. So it's not something that's new and only just been done. We can go back over a long period of time and see what's happened. And what we know is that if we do follow the international protocols, which we do, and we recommend that you do, that's how we work, and we do proper safety testing, that we can predict with certainty what plants will be attacked. And so for all of those natural enemies that have been released all throughout the world, there's only 4 that are considered to have population level non-target effects. And they were all predicted or predictable using the techniques that we use now for testing. So sometimes people went ahead anyway. They knew that there would be some non-target attack, but they decided that was the lesser of the problems. And research is continuing to look at how we can improve safety, and that's some of the work that my team are doing here. But actually it's more around now making sure we don't reject perfectly safe agents by being too conservative. So looking back over the 100 years and the data we have, we can be confident that we can predict what will be attacked and what won't be attacked. And we need to make the choices based on that information very carefully. Right, so we're going to hear from you guys now. Again, we're going to get your phones out. And we're going to go to Mentimeter. Tell me if you think natural enemies can successfully control weeds or not. Yes, no, or don't know. It looks like I'm speaking to the converted. Lots of confidence that it can work. A few that don't know. If you can you give us an example of a successful project or a natural enemy in the Pacific that you are aware of? We got any examples? Lantana, broomweed beetle. Great. Mile a minute, Mimosa diplotricha. Lots of people know about lantana. It's Michael's favourite. If you ever go out in the field with Michael, he'll show you lots of lantana. You always have to stop and look at the lantana. Okay, and we've got a few other things that are not to do with weeds. Okay, thanks for that. So does it work? Again, with our 100 years of information, someone's crunched the numbers, and about a third of programs are so successful that you don't need to do any other control. That's it, you release the natural enemy and you never have to do any other control for the weed. About half are partially successful. So that means they might work in some habitats, but not in others. So they might work in the wet sites, but not the dry sites, or the shady sites, but not the sunny sites. And about 1/6 are not successful and they have no impact. Now, what usually happens is funding runs out before a project or all the options can be explored. If funding was never a constraint, we would have fewer of the ones that have no impact because we could succeed with them if we had the time and the funds. So it's not that natural enemies can't work, it's often that the funds run out before you can explore and find the successful approach that you need. But we're also continuing to do research to get better at picking which agents will be the best, which ones will be the winners, and how to do it faster and how to do it more cheaply, because I didn't mention it earlier, but every country has got not just one or two weeds, you've probably all got hundreds. And so that's one of the slightly depressing things about working with weeds, is just the sheer number that we're going to have to manage. So we need to be able to do this more quickly and more cheaply if we're going to get on top of enough weeds fast enough. But our approach in the Pacific of using the ones that are tried and true increases the level of success. So the broomweed beetle popped up in that previous slide. We knew that it had been very successful in Vanuatu, for example, and in Fiji. So we can be relatively confident when we release it in Tonga, Niue, other places, we're going to get a good result because it's a tried and true. So where is it best? And this picture here is, if you're wondering what it is, this is a plant called hibiscus burr. The Latin name is Urena lobata. This is taken of Vanuatu, and this is one of the weeds that we are developing natural enemies for. And that's supposed to be pasture there for the cattle, and a lot of weed and not much grass for the cattle. So we're hoping to do something about that. We actually have a natural enemy here in our facility in Auckland that we are studying to see if it will be suitable for releasing against the hibiscus burr. So where natural enemies is best is where you're not wanting rapid eradication, or where it's just not possible. Where there's no other way of controlling the weed, or by using other methods, you just cause too much harm. When it's just not physically or economically viable to use other methods, it's just too expensive, too difficult, there's too much. But also where people accept it. You don't want to be picking fights with your communities. And so there's always a bit of work to do to have a conversation with the community about this approach, and to talk through the worries, and to talk through the benefits, and to talk through the harm that will be done if you don't control the weeds as well. Because people often don't think about that. If we let the weeds go, there will be damage to the ecosystem services, to livelihoods, to biodiversity, human health, animal health, fresh water quality. And so doing nothing is not an answer, not an option. But we need to be sure that the NEMS is the best option. So now I'm going to hand over, and Michael's going to talk through just some Pacific case studies.
Okay. So thanks, Lindy. I just wanted to touch, before I go on to some of these specific case studies, just give you a bit of information about the Pacific in terms of biocontrol. So over 60 biocontrol agents have been deliberately introduced into the Pacific to tackle 25 weed species. And 17 of the Pacific Island countries and territories introduced a biocontrol agent. So that's only 4 countries have not deliberately introduced. So all of the countries represented, or nearly all of the countries represented today, have deliberately introduced a biocontrol agent at one stage to control a weed. So some of those countries haven't done anything for 20 years, and this is partly why we're having these courses. So some of the successes, I'm only going to touch on a couple of the successes, but there's a number of successes. I've listed about 6 already here: water hyacinth, salvinia, pistia or water lettuce, cider, we mentioned that in the, when you put in your Mentimeter responses, Mycania, they've all been some tremendous successes. And we'll talk about that, we'll just touch bases on a couple of those. So next slide, please, Lindy.
Do you want to just say, first of all, what the slide is we're showing? Do you know, or do you want me to explain?
No. So this is taken in the Cook Islands. The photo on the left is a series of weeds. There's Cardiaspinum or balloon vine. There's Mycania in there. There's Passiflora in there. And the New Zealanders with Quentin released a number of biocontrol agents to tackle these vines, because if you took out one vine, the other vines would just persist and fill up the spaces. So they released 3 agents on the 3 different vines, and each vine had to have its own agent. And you can see, I think this is 4 years down the track, but you can see there's hardly any vine in the photo on the right. And as Lindy says, things happen in the Pacific quite quickly. And so the monitoring processes we do is a lot more frequent than others in other countries. So this is just one example, a spectacular example of work done in the Cook Islands. And these agents are available for other countries if they've got these weeds as well. So African tulip tree, this is Spathodea campanulata. It's found in most of the Pacific Islands and countries. There's a mite, Colomeris spathidi, which was tested in South Africa on behalf of the Cook Islands and the New Zealand funded project. The mite forms gauze on the leaves and the new shoots, and you can see Lenny's pointing to that there. But in the new shoots, it actually stops the new growth, and it can also reduce flowering and seeding. This mite was introduced into the Cook Islands, and we're actually trying to now looking at getting it into Tonga and Vanuatu and other countries which where African tulip tree is deemed a problem. And then there's a new flea beetle also tested in South Africa on our behalf, which mines the leaves, and then the adults feed on the beetles, and that's going to be introduced into Rarotonga in the near future. And hopefully between the two of them, they suppress growth and flowering and seeding.
I might just add, we have that beetle here in our containment facility in Auckland, and one of my new staff who's on this call, she brought it over in her suitcase from South Africa for us a couple of weeks ago. So thank you, Alana.
Mm-hmm. Next slide, please. So broomweed beetle or broomweed, Cider acuta and Cider rumbifolia. People mentioned that, Lillian talked about it earlier. This has been a tremendous success. The weed is found in 22 of the PICs in the Pacific, and this beetle was introduced into 4 countries. It's only established in 3. I don't believe it's been found in, recovered in Samoa. But in the 3 countries where it has established, it has, which is Papua New Guinea, Vanuatu, and Fiji, it has tremendous successes. So we'll just go on to the next slide. So this is work done in Vanuatu in the early 2000s. You can see a paddock on the top left that was just outside of Port Vila on the main island of Whaiwhate. That was before the release of Calligrapher. And then you can see 3 years later, that paddock is virtually clean of cider. That little clump just to the right where Linley is, that's a little cider plant. And you can see, if you look carefully, you can probably find 1 or 2 plants scattered through that paddock. But on every single plant, you can either find some larvae, some eggs, or the odd occasional adult. And the farmer doesn't do any more work on that paddock. The beetles is just there. And if you go driving around Whaiwhate or PNG or Fiji for that matter, you still see the plant, but it's not in the same dense infestations that it was before the beetle was released. And this is another activity that we're going to be doing under the NEMS project. We're going to introduce Calligrapher into Tonga and Niue, and Haggard from Niue has just received a import risk assessment from me, which he'll look over and provide a bit of feedback. And then hopefully we can get that beetle into Niue in the next month or so. Next. Giant sensitive plant, Mimosa diplotricha. That was one of the weeds that people put up on their Mentimeter. This weed is found in 16 of the countries. And the little psyllid, you can see it in the top right, has been introduced. It's actually introduced into 13 countries, but it failed to establish in 1 of the countries. And in all 12 countries where it has been introduced and established, it has provided sustained suppression of the weed, where the weed requires little or no additional management. In fact, in Papua New Guinea, it's very hard to find the plant now, whereas in some areas the weed was quite common, and now it's very, very rare and it's hard to find. In other countries such as Fiji and especially, it's also hard to find the plant. So great little insect, and if the other 4 countries in the PICs would like to, if Mimosa diplotricha is a problem, we can certainly introduce this little psyllid to there. Just that one little comment about the psyllid is that there's also another plant called Mimosa pudica, which is also a ground cover plant, also a bit of a problem in many countries. But this little psyllid is so specific, it won't attack that other mimosa plant. And it also won't attack Mimosa pigra, which is a giant sensitive plant found in Papua New Guinea, which grows to 3 or 4 meters. It won't attack that. So it really, some of these biocontrol agents or some of these natural enemies are so specific that they won't attack other species, even in the same genus. Another one, grand balloon vine. We touched on this briefly in the very first slide, which with all those weeds in it. Very serious invasive vine in the Cook Islands and many other countries in the Pacific. New Zealand introduced this rust fungi in Rarotonga in December 2017, and we were over there in 2019, and within 2 years, a lot of the weeds had disappeared or had been reduced, I should say. So the top photo, you can see that that vegetation or that bush, that tree was covered in the vine in December, and a year later, you can see that you can actually see what plant species it is. So the rust worked extremely quickly, and you can see that the damage that Lynn is pointing to it there in the bottom left. One of the nice things about working with rust is that the life cycle is a little bit quicker than most insects. The spores, there's thousands or zillions of spores being produced, which are blown by the wind, and the effects can be very, very dramatic. So if you can find a good rust, the results can be spectacular. And we've seen that with balloon vine and Mycania. Lantana, many of you talked about Lantana. It's found in most of the countries in the Pacific. It's been a target worldwide for over 100 years. And over 20 natural enemies have been introduced into 15 of the picks. Uroplata, the leaf-feeding beetle, is up the top beetle, and the leaf-sucking bug, Telenemia, is in the bottom. They're putting the two most damaging insects on Lantana in the Pacific, and they've established on 13 countries. And so that leaves us about another 8 countries which could introduce these insects into those countries if Lantana was deemed a problem. And I should say, just because a country may have a weed doesn't mean to say that they need to do biocontrol, because in some countries these weeds might just persist. Like in Nauru, for instance, you may not get large infestations of Lantana, and so you may not need to implement biocontrol. But so we're talking about species which are actually causing environmental or economic harm, and then those countries can implement biocontrol if they feel free to do so, or if they think they need. Next one. A few people mentioned Mycania. This weed is also found in most of the countries in the Pacific. We released a rust, Puccinia spegazzani, in Fiji and PNG, and we got some tremendous results in those countries. From PNG, it was also introduced into Vanuatu, and then from Vanuatu, it was introduced into the Cook Islands. And we've seen good results in all of them. And we've also heard that the rust is now in the Solomon Islands. It was pretty naturally introduced or spread by natural means, but it wasn't deliberately introduced as part of a biocontrol project. And many of these agents do get blown around in the wind or in air currents. So it's always a good idea to check to see if you've got an agent there already before you release. In most of the places we've monitored in PNG and Vanuatu in particular, where I've been spending most of my time, there is a lot less Mycania there than it was before we introduced the rust. This is in Rarotonga. You can see in the top left, there's more than just Mycania in this photo, but you can see in the bottom left, well, bottom right, I should say, the same site roughly 2 years later, and a lot of the weeds, Mycania, balloon vine, and Passiflora have all virtually disappeared because of the combined effect of the agents on each of those three weeds. So tremendous results in the Cook Islands. And I should point out that the Cook Islands, Lindy touched on this before, but often targeting number of weeds is far better because it doesn't, one weed doesn't replace another. And the Cook Islands is a prime example of where a number of species were targeted and agents were released on each of the weeds, and you can see there the results, all within 2 years. Great result there. Water hyacinth, it's got a new name, except the new name now, Pontidaria crassipes, found in most of the Pacific Island countries. And there's been 2 weevils introduced, Neocotina eichhorni, that's the one on the right, and Neocotina brucki, which is the one on the left. And if they're released together, you get a far better result than if you release one of the beetles by themselves. And there's been some great work in Vanuatu and Papua New Guinea. These photos here is in Vanuatu. The top photo shows water hyacinth in the Tuma River on Efate in 2004. And 4 years later, you can see that river is virtually clean of water hyacinth. There's still occasional plants along the edges, but the beetle just keep it under check. I don't know if we don't have photos of what happened in Papua New Guinea, but there was a very successful project in Papua New Guinea where the photos were equally dramatic. Water lettuce, Pistia stratiodes, is found in over half or nearly half the countries. This little weevil was introduced, Neohydronymus, has only been released in 2 countries, Papua New Guinea and Vanuatu, but both with resounding successes, and is controlling the weed in most of the places where the weed has established. And you can see it's a tiny little beetle. You can see Linley's cursor is pointing to a beetle on a pistia leaf. You can show how small it is. And then if we go on to the next photo, this is in Vanuatu on the island of Espirito Santo. The beetle was released on this large pond in 2005, and you can see 3 years later, virtually all the pistia has been removed by the beetle. And this is not flushing due to floods or currents. These ponds are part of a property, so the water doesn't actually flow anywhere. So it really does show that what biocontrol can happen in some situations. Next photo. All right, I will hand you back to Linley.
Yes, so that's just a bit of a flavour of some of the projects in the Pacific. It's not all of them by any means, and there'll be some homework coming soon to find out a bit more about what's happened in each of your countries. But first of all, can you get your phones back out? And we're going to ask some questions. So does anybody have a question in relation to the material we've just covered that they'd like an answer to now? If you have a question, type it in to Mentimeter. Not sure if there are no questions or it's taking a long time to type them in. So we'll just give you a few more minutes. Could you please have the PowerPoint? Yes, we're going to make the PowerPoints available afterwards, and Joseph will put them on the shared drive where there's other documents as well. So I mark that one as answered. How soon can we have NEMS? That's a good question. I'm going to have to find out who you are so I can talk to you. I'll get you to submit me something else so I know who I'm talking to, and we can answer that one offline. Are there any more questions? Is that a question? Hasn't come through. Oh, there are more questions coming through. I have to click that one. Sorry, I just need Temo to give me some advice here about how I get these other questions up. This is the first time I've ever used Mentimeter, so we're just figuring out how we get some of these questions that have popped up on my screen. Okay. So I just have to move this so I can actually read the question. Can I make that smaller? That one. Do biocontrol agents survive when there is no host? No, they die. It's unusual for there to be no host permanently. Sometimes there can be a period of time where the host has been wiped out and then they will die because they can't feed on anything else. But usually there's still some host somewhere. And so it's unusual for a weed to be eradicated. Normally we just end up with, like, thinking back to that picture that had the broomweed, and we could still see in that paddock a couple of clumps of the broomweed, and we knew there'd be beetles on it. There's just less of the weed and there's less of the agent. But if they are a bit too successful and they eat all their plant, they might get localized extinction, but it doesn't tend to happen over the whole landscape. Thank you for a informed presentation. No question from Vanuatu. Thank you, Vanuatu. Can you give us an example of an initial cost? Okay, one of my colleagues, Quentin, who's going to join us for session 5, has written a paper looking at the costs for New Zealand. And I'm talking in New Zealand dollars here, so you'll have to do your conversion. If we're starting with a completely new target, something that no one's ever worked on, ever anywhere in the world, and we have to do all of the research, you're looking at maybe $2 million New Zealand dollars. So that's not cheap, and we have to look to large donors like New Zealand's MFAT to help to support that kind of work. But where there is already a project where people have done the research in another part of the world, for example, and we only have to do maybe a little bit of testing for New Zealand, we're basically repeating a project, then we can get that cost down to maybe a quarter, 500,000. And when we're working with you guys in the Pacific, because often we don't need to do much more testing because your floras are the same, we can get this down even lower, but it really just depends on whether we need to help with things like building infrastructure and whether we do need to do any testing. So I don't know, Michael, what's the cheapest project you've ever done? I know Michael's good at doing things on a shoestring.
$1,000.
He's done one for $1,000.
So
yeah.
one of the things Lindy's touched on depends on how much testing is involved. But I've often had requests from various countries to introduce a biocontrol agent, and they just have to take it through one generation and then they can release if they accept the previous testing. So, but there's all these other factors. Lindy mentioned if we need to do other testing, whether we need to build facilities, and each country is different. And so it's very hard to give a figure, but if there's, in a best case scenario, it's very cheap to move insects around the place, but we do need to make sure that we're using the right techniques, we're following the right protocols. You know, we don't want to be embarrassed by taking shortcuts. We don't promote that at all. So while that can be very cheap, but new projects can have an initial outlay which can be expensive. And so it's a case-by-case situation.
We can work out what it's going to cost when we know what's required, what a country's interested in. Have any scientific research with figures been conducted? I presume you mean the cost benefit. That's not been done yet, but we would love to do that. It's always really powerful to have that information. We've been meant to be going back to Cook Islands to do some more follow-up. Of course, we haven't been able to go under COVID. So bring on those travel bubbles. What's a rough estimate? So we've already described that, answered that question. How can we be sure that other species aside from the target will not be damaged? We're going to cover this in some detail in session 3, the testing that we do so we can be sure. So we'll park that one up to session 3. Thank you for all these questions, by the way. It's great to have so many. What do you need to do to get an assessment done on invasive weeds in country? I'm not quite sure what you mean. Do you want, is that about what species are present or which ones should be tackled for NEMS? Perhaps you could submit me some more clarification around that question.
Well, I'm just thinking, one of the things that we often do with when we start up a biocontrol project is we look at things like impacts, whether farmers or biodiversity has been affected by a weed. So that's one of the things that countries do look at, whether there's an initial impact or a perceived impact by farmers. But it's a bit of an open question, so we may need more information on that.
Now, just this next question here, the natural enemies that we use are insects or invertebrates. So we use mites as well, which are not insects, but are invertebrates, and fungi. We don't tend to work with any other plant pathogens. We don't tend to work with viruses, for example, because they're too difficult to work with or less host specific. So we only focus on working with the things that we know that are trusted and true. Haven't had any involvement in using natural enemies for marine. I know that marine's another whole big problematic area. Any cases where biocontrol failed or weren't successful around the region? Well, Michael gave some examples where some of those agents were introduced and didn't establish. Michael, do you want to comment further?
There's been a number, and if you look at one of the comments that Lenny made earlier, where she mentioned that 1/6 of biocontrol projects have failed or weren't successful. So one of the ones in the Pacific was Cyperus rotundus, nutgrass. 3 agents have been introduced onto that one, and some of the insects have established, but they're just not controlling the weed as people would like. Some of the agents which were introduced onto lantana are the same. They've established, but they just haven't done a level of control that land managers were hoping for. So you still see lantana around, you still see nutgrass around. And there's a few other weeds like that where successes weren't quite what we'd like them to be. And some of these weeds we can go back and revisit if they're still a problem. Others, it could be that there are just no agents which are host specific, and that's important. So one of the questions was, how are we certain that the insect or the biocontrol agent won't attack anything else? And sometimes when we go looking for biocontrol agents or natural enemies, it's not possible to find a natural enemy that only attacks that weed. It attacks other things, and so we can't release it. And so that's where some other projects may not work or may not be as successful as others. We haven't found something which is a natural enemy which only attacks that weed. And as I said earlier, some of the natural enemies do establish, but they just don't do what we'd like them to do. They're just not controlling the weed or feeding on the weed as we would like.
So we're not going to promote natural enemies we don't think are going to be successful either. We know which ones are the tried and true. How do you know the quantity of NEMS to release in the environment? You actually only often need a very small amount, maybe 100 beetles or a very small amount of rust spores. We know that for each individual natural enemy, we have a pretty good rule of thumb for what's required, and it's often relatively small. If the host is finished, is there any possibility for the control agent to feed on other beneficial hosts? This is something we work out with the host testing we're going to talk about in session 3. So sometimes there is absolutely nothing else they can feed on, and we know that won't move on to anything else. And other times we know there are other hosts, maybe less optimal, and then decisions have to be made about whether you proceed, whether that would be acceptable or not. What if they invade other non-target plants? Will they run out of weeds? And again, we're going to talk about this in more detail tomorrow, why they're not going to run out and attack other. So stay tuned. You'll have to come back tomorrow to get the answer to that question. Thank you for having us in this training. Wonderful. Thank you from Vivea. What are some of the challenges you faced in terms of introductions? Well, there's all kinds of logistics, I have to say. At the moment, we're trying to find couriers who will actually take insects on planes for us so we can get some of these things in country. Sometimes it's just working through getting the infrastructure, getting the permissions, training people so that they can rear and release agents. We're going to talk about some of the challenges as we go through the next few sessions of the actual doing, how you actually enact a project. None of them are insurmountable though if we're all passionate and committed. How feasible is getting an introduced species? It really depends on the country. Some countries have very good processes and will do it very quickly. Others will take longer, particularly if it's something that hasn't been done before or done for a long time. If you've got risk-averse people, but if there's a willingness, then again, we find sometimes we can get permits and everything sorted within a couple of months. Which characters is more important when choosing a perfect candidate? Okay, the perfect candidate breeds really fast and is really hungry and doesn't attack anything else. And we know there's certain kinds of beetles, for example. If we find one of those as a natural enemy, we know they like to be successful. And we know certain kinds of fungi, like rust fungi, are often very damaging and very specific. So we are learning which ones, often mites are very host specific as well. And over time, we're learning more and more about how to pick the ones that are going to be best. Thank you so much for those questions. That was really, really great. And I just want to check in that you're able to follow us. I know I'm talking in a funny accent. Michael's got an even funnier accent than me. Are you able to follow? Are we speaking too fast, too slow, using too many big words? 100% yes. Okay. So the next slide I was going to say, if you thought there was something we could do better, or if we were using too many big words, etc., you can give us some feedback on the session or any suggestions, seeing as we have another 4 days and we're learning as we go. If you want to submit some feedback to us, and we will have a debrief after the session and talk about whether we need to do something different or more of the same. But now I'm actually going to hand over to Michael, and we're going to look at his screen, and we're going to talk about the homework. So Michael's going to talk you through how you're going to find out, if you don't know, what natural enemies your country or territory already has. And if you can, it would be good if you could find out if we know, for example, whether they are widespread in your country or just confined to one island and there's more work to be done. That would be really good if you can ask around and find out. So I'm going to stop sharing my screen, and Michael's going to share his screen.
So this spreadsheet here, there's a number of pages on it, but I'll just go through the page which is open now. What we did to do this exercise is we listed or went through various databases, and you can see that on the top row. This is a complete list of weeds, and you can see the ticks if they occur in a particular country. And I'd welcome feedback if you if there's a tick in your country against a weed which shouldn't be there because the weed's not present, or if you've got a weed and it's not marked for your country, I'd also welcome that. And then what we did was we looked at the weeds in your country, and you can see all those lovely colours. All those weeds there which are highlighted in colour are weeds which have been targeted for biocontrol in at least one country worldwide. And I'll go through the colours in a minute. If you look on their next, and also the ticks apply to whether that weed is in your country, not whether the biocontrol agent is, but whether the weed is. Then the next tab is, this is the biocontrol efforts in the Pacific as to date. And so you can see, you can ignore column A, which is a list that's got A, B's and C's in it. You can ignore those. That just refers to whether or not agents have been deliberately released or just moved. You've got a weed family, weed name, and then then there's a few columns about the agent, then the country of release in column H, whether it has established, whether it's abundant, and the general impact, and then some geographic scale. And a lot of it, you can see in the top row there, there's an unknown, it's variable, or it's widespread. And we can look through that. Then we move on to, this is probably the best place to get your, you can get your information from the releases, if you like. So if you want to know, let's do one here. We click on the tab. So I'll go through that slowly. So I'll start again. So to look at what you've done, what's happened in your country, there's a little down arrow here. Click on that. Click on select, unselect all. So you don't get any little marks here. Click on your particular country and then click OK. And then you can see what's been done in your country. And so for American Samoa, where you're going to be on, you've got an easy bit of homework. There's been 2 agents introduced, and you can see the weeds that have been released against, whether the agents have established, whether it's high abundance or limited abundance, the general impact, and you can also see which geographic range they've had. And then there's some general notes about on the impact. So in terms of what natural enemies, I would use the picked BC releases tab, and that just gives you a snapshot of what has been released in your country. The other tabs we'll talk about a little bit later on. This is regarding options for countries if they want to release natural enemies in their countries. So I might just leave it at that. I don't want to confuse you with too many spreadsheets.
Can I just make a comment, Michael? You've got the common names tab.
Well, I thought I'd ignore that one for the time being because we're going to talk about that later on. But if you want me to talk about it now, I can. So in this tab here, common names, what we're trying to do, these are all the weeds which are targets for biocontrol. They've all got colours against them, and we don't need to worry about the colours at this stage. But we're trying to capture what the common name is for each of these weeds in each of the countries. So if you want to, feel free to fill in this table as much as you can. It doesn't need to be done overnight though. What we'd like to see you back for tomorrow is just working out what natural enemies you've already got in your country, what's the current distribution, and whether or not you think that there's a need to move it around. And this probably more applies to countries like Papua New Guinea or Vanuatu, Solomons, Fiji, where there's lots and lots of islands and the agents may not have been moved or released on all islands. So we can have a look at that. I think I might just leave the other spreadsheets to later when we start talking about options for the future. As I said, I don't want to confuse you with what's on there, but this file is available for you on the SharePoint, I believe, Timo. So just go to the Pick BC Releases tab, and as I said, just use those filter buttons to scroll down to each of the countries to see what you've got.
So just while Michael's pulling up his other file to show you, a project that we are working on is to make all this information available on the web for you. So Michael's been busy updating what weeds are known to be in what countries, what natural enemies are known to be released, and we're going to do fact sheets also for how do you identify each of these weeds. And then we have another whole piece of work that Quentin has done about which weeds are likely to be the best targets. And we're going to bring that all together somehow. We haven't quite worked out yet the best way to do that, but make it much easier for you to be able to go in there and to search and to query and to find out what the options are for your country.
The file was put into a paper. This is available online, and it's also going to be made available to you. This just gives you a snapshot of the weed biocontrol efforts in the Pacific, but it's not in searchable format, but that's available for you as well. You can go look through that, but the Excel file is probably the best one to easily extract information for you to do this particular exercise, and also when we do the exercises about choosing possible agents to introduce into your, or natural enemies into your country. And then the other thing I want to just show you very briefly, this is the paper I late Severio in Vanuatu, and what we did was we just took Vanuatu as an example, where we looked at the status of weed biocontrol in the country, and we also discussed options for the future as well. So this was just a snapshot of what's happened in one country, and various other countries, Fiji, Papua New Guinea in particular, have all done a lot of weed biocontrol work, and we could do something similar for those countries as well. But this just gives you a bit of a snapshot of what we can do specifically for one country to show the status and what could be done in the future. So I haven't made that one available, but I can.
So Michael, do you want to stop sharing now?
I have stopped sharing.
Thank you. So we've actually reached our 90 minutes and we're going to close off now. Thank you very much for all coming online to participate today. Thank you for using the Mentimeter. It's been really great to get your feedback and your questions. And we really look forward to seeing you all tomorrow at the same time, and we'll get into session 2. So from me, ka kite anō.